Hello, my name is Wura Olaoyewuse, and I'm presenting this paper with my colleagues Sharon Ibeji and Okweyemi Oshakwade. This paper, NaijaNER, Comprehensive Named Entity Recognition for 5 Nigerian Languages, was co-authored by Olubayo Adekombi, Ifeoma Oko, Victor Onuigwe, Mary Idera Salami, Usman Abdullahi Musa. We are all with Data Science Nigeria. This is a presentation at the African NLP Workshop, EACL 2021. Here are links to the paper, the web app, and the GitHub link for the models that we used. Most of the common applications of named entity recognition is on English and other highly available languages. In this work, we present our findings on named entity recognition for 5 Nigerian languages: Nigerian English, Nigerian Pidgin English, Igbo, Yoruba, and Hausa. These languages are considered low-resourced and few openly available natural language processing work has been done in most of them. In this work, individual named entity recognition models were trained, and we recorded the metrics for each. We also worked on a combined model in an attempt to do named entity recognition on any of those 5 languages with a single named entity recognition model. At the end of the project, the combined model, it works well for named entity recognition on the 5 languages that it was trained on. And of course, we expected better performance with individual NAR models that were specifically trained on data annotated in a specific language. The aim of this work is to show our learning on how information extraction using named entity recognition can be optimized for the listed Nigerian languages. We hope that it encourages inclusion, ease of deployment of these models in production, and reusability of trained NAR models. All the code and the model of this work, they are openly available on GitHub, and there's also an interactive web app. Okay, so named entity recognition is sometimes referred to as entity chunking, extraction, or identification. It is a subtask of information extraction in natural language processing. It involves processing text and identifying certain occurrences of words or expression as belonging to categories of named entity. In this project, we explored the major named entity recognition. Okay, we'll talk more about that. There are more than 7,000 languages that are spoken across the world, and only a small fraction is considered high resource. And what makes working with Nigerian languages interesting? Well, the statistics is not clear. Sometimes it's assumed that we have up to 120 million people in Nigeria. Some people argue that it's up to 200 million, but several languages are spoken in Nigeria, and we worked with 5 of them. There's a caveat to this. We have a Nigerian English, which is not different from normal English, but in this context, we analyzed the named entity recognition for Nigerian English. That means that the entities were labeled in the context of what happens in Nigeria, in the context of the kind of organizations, the kind of names, the kind of the kind of number, a little bit of code switching. So that is what Nigerian English stands for here. Okay, Sharon is going to talk about the methodology, and so Sharon.
Okay, so for this research work, we got our data from 50 articles. So for each language, for each of the 5 languages, we made use of 50 news articles. And after getting our data, we did data annotation using Tag Editor. Tag Editor is an open source software for annotation, and it's easier because it has spacey annotations there. So all entities that were required for this project were used from the Tag Editor. And after that, we made use of spacey for our model development. We have spacey blank and then the English spacey model. So for our Pidgin and English models, we made use of the Spacey English model since they had similar vocabularies. But for our native languages, that the rest of the 4 Nigerian languages, we made use of a blank spacing model. So for after annotating our data set, we had to split our data into 80% for training and 20% for evaluation. And then for our paging, as you can see in the table, we have 1,048 for paging and 105 for the evaluation. And just like that, up to NaijaNER, which is the combined Nigerian model for which we expect to perform good enough for 5 languages. So we had 5,697, which is the sum of all the training data from the individual languages. And for the evaluation, we have 1,135. Next slide. So after training our model, we discovered that the F1 score for the Nigerian Pidgin and the Nigerian English were higher than the NaijaNER, which is as expected anyway, because we trained these 2 models on Spacey English model, and we assumed that based on the fact that it's a pre-trained model, the models would perform better. It became more robust to our language. But for the native languages that were trained on the blank model, the F1 score were quite low. And then there's room for improvement because these are results from 50 articles that were split into train and test. Next slide. So these are samples of our model. So we tried the comparison between the Pidgin model and the NaijaNER model. And then we can see that the Pidgin model was better off than the NaijaNER model. Comparing the, like for example, we can see that the name here, Justice Tanko Mohammed, was recognized in the NaijaNER model as an organization, whereas in the Pidgin, it's a name of a person, along with some other differences. The next slide. So coming over to the Igbo NER model, the NaijaNER model performed better in terms of recognizing a name, Ukochukwu Elliot Ugochukwu. So it shows that there's the model is robust enough to understand the native language. We could see how it's recognized Pidgin, even though it made some mistakes. It also recognized native language Igbo and performed quite well like the Igbo model did, and even recognized a name which the Igbo model could not recognize. The next slide. So we'd look at the Yoruba, which is one of the major languages in Nigeria as well. And we can see that down here we are having our NaijaNER model on Yoruba text. So this model performed quite well, like the Yoruba model, but both of them made mistakes. They were not so perfect. They had their mistakes. And we can see from here in the NaijaNER model that it's recognized Lori as person. Lori in English means on, just like on top. And then we have PDP. PDP is a political party in Nigeria. It's recognized as a person. Daily Sun is a newspaper company in Nigeria, and it's recognized as person as well. So these are little mistakes, but we can say here that it's saying Daily Sun as an organization, which it is. So these are little mistakes that both models made. Can we go to the next slide?
Okay. So my colleague gave a basic comparison between these models. We saw better performance in the combined model because obviously there's the advantage of a bigger training data set, learning pattern from more than one language, and there's a caveat that throughout this paper, this is a very small data set. This is a very small data set, just about 50 articles. It's not a big data set in terms of what we are doing at all. And but we were able to we can see that on most of the languages, the combined model, the combined NER model called NaijaNER, was able to perform well to an extent. That means that rather than deploy multiple models, depending on a user-specific use case, you may be able to leverage just a single combined model. In this case, NaijaNER. Okay, in conclusion, this work explores individual and combined named entity recognition in 5 Nigerian languages: Nigerian English, Nigerian Pidgin English, Yoruba, Hausa, and Igbo. The choice of when to use a combined or an individual model is dependent on the user's interest. That means in your use case, if you want something more specific, you may be willing to use a specific language model. If depending on what you're trying to do, putting it in your app, or you may just decide to explore the combined model that can work on more than a language. The combined NER model, NaijaNER, is versatile for multi-language application. It has good performance, at least in the context of what we did here on small data sets in each classes, on each of the languages. And of course, as we expect, the language model showed better performance. It's more granular than their specific languages. All the metrics per entity were provided in the main paper. Let's say you're looking at a specific entity, you're looking at maybe extracting Igbo names or Yoruba names. You can read through that. We provided all our findings, and we think that combined entity recognition models that works well with different languages, we think that it can be a valuable tool in low resource system where you can combine that the model can handle more than a language. We hope that it can drive inclusion. We hope that it can ease deployment in production, which is a popular question in machine learning, AI. How is this deployed? So rather than deploy individual language models for each language, what if you train a combined model and you deploy just one? And reusability of NER model, that's part of, even though many of the F1 scores, they were quite low because of the small training data set. It's open. You can decide to train more on it. You can decide to start your training on us. So all that is provided in the GitHub link. So my colleague Opeyemi will take us through the web app link. Opeyemi, are you there?
Yeah.
Do you want me to project from here, or you want to share your screen?
I'll prefer to share my screen.
What did you say? You share your screen?
I prefer to share my screen, yes.
Okay, so I'm going to stop sharing my screen so that Opeyemi can show what the application looks like. Okay, I've stopped sharing now. Okay, you have the floor.
Can you make me a co-host so I can share?
Okay, Sharon. Or do I change that?
Okay, no, yeah, right, you have to be done to do it.
Okay. So I'm making my colleague Opeyemi the host so that she can share her screen. Okay, Zoom said I can't minimize. Okay, Opey, you should be able to share your screen now.
Yeah.
Okay, so Opey is about to show a demo of what these models look like in form of an application.
Let me know when you can see my screen.
Opey, your screen is visible.
Okay, I'll be going through the demo for the app, for the NaijaNER app. This is the landing page, and we have description of what named entity recognition is here. And this is where you select which model you want. The names of the model shows the languages also. You have Yoruba NER, NaijaNER, Nigerian English NER, Igbo NER, Hausa and Pidgin NER. The NaijaNER is the combined model. So let's test, let's show this. Picking this is showing the description of the NaijaNER and the F1 score and precision score. You also have options of using a sample text. You can enter your text. You can enter your text by typing here.
You can also get text from a URL by getting, you can enter a text from a URL and you can also upload your text from your computer. Let's check sample text. For the NaijaNER, you have sample text of English, Hausa, Igbo, Yoruba. So let's check for English. Let's test on English and see the result. You click on the submit button. Then you wait for the model to load and give a result. For long text like this, you can always show and hide the results so you can go through. This is showing, this is highlighting different name entities in the particular text. You have persons, events, dates, and organizations and all. You can, from this app, you have a table showing you the text, the kind of label, where it's starting in the sentence, and the number of characters and all. Then you can also download this for reference. You can download this and save. This shows you a TXT file of this. Let me show you. I hope you can see this. This shows you a TXT file of the table showing shown on the web app. For more understanding of each named entity, we provided a glossary column, a glossary tab where you can check description of each named entity for better understanding of the named entity. I hope you enjoy using our demo app. Yeah.
Yes, we enjoy doing that. We'll update from any NLP app to NaijaNER app. Okay, thank you for listening. We look forward to your questions. It's open on GitHub. We've put it on Archive. We put it on ResearchGate. See you at the conference. Bye-bye.
Bye.
Bye.